just covered. Generally speaking, the questions in each section relate to something you learned in that section. So you're going to need to use at least one thing you learned in the section. So it says, find a vector parallel to the line of intersection of two planes. Now, are you expected to draw these planes perfectly? Does it even ask you to draw what this looks like? No, but it really helps if you do. So the idea of what you're seeing here is you have one plane in space like this, and then you have another plane like this. And what does it tell you they intersect to form?
A line.
They intersect to form this line right here. So they intersect right here to form this line. Correct? So let's say let's call this one plane A. The relative positioning is irrelevant. And let's call this one right here plane B. We okay with this so far? A and lowercase b. I'll be consistent here. When you're looking at it says find a vector parallel to that line. Okay, there's many of them, right? Magnitude is what's going to matter. Sorry, direction is what's going to matter, not the magnitude. So when you're given an equation of a plane, what are you automatically given when you're given an equation of a plane written like that? The normal vector. So for A, what do you know the normal vector is for A here? 2, -3, 5, right?
Oh, even though it's not 0? It's not equal to 0?
Doesn't matter. Yeah, the coefficients dictate the normal vector completely. Everything else, it doesn't tell you anything about a point on there, but everything else, no. So NB here, what's a perpendicular vector to B?
4, 1.
4, 1, -3. So that's what you automatically have. All I've done is draw and write down things that you automatically had. We haven't done any manipulation yet, right? So here's the thing. Graphically, what do we have? We know that the normal vector, so let's say this is a point on A. This right here represents some normal vector A, right? This right here, let's say that's on B, going out like this. That represents NB. Those two vectors, they are perpendicular to the planes that they are stuck to, correct? Therefore, you know, you see the purple line of intersection right there? What can you tell me is the relationship between NA and the purple line? They have to be what? They have to be perpendicular. And what do you know about the relationship between NB and the purple line? They have to be perpendicular. So if I have two things that are, if two things are perpendicular to the same thing, and I cross them, so if I find something that's perpendicular to both NA and NB, what does it have to be parallel to? It is the cross product. The intersection of the two planes. That's what I'm getting at here. So if you have something that's perpendicular to both NA and NB, it has to be parallel to everything that's perpendicular to both, right?
Which is the line of intersection.
Exactly, which is one of those things is a line of intersection. So paranormal vector? What do you mean? I don't know what a paranormal. I mean, it's like paranorman. I'm very critically acclaimed music. It might be. I don't know that term off the top of my head. But let's finish this one first, okay? All I'm saying is you know that NA, right, has to be perpendicular to purple, right? Because purple is part of A, right? And you know that NB has to be perpendicular to purple, correct? Therefore, when you do, and you know that NA cross NB has to be perpendicular to both NA and NB, correct? I'm just writing out what we just said. We know that when you cross them, when you cross two vectors, what do you get? You get a vector that's perpendicular to both. So this new vector we're going to get, let's call it, say, vector, I don't know, C. Therefore, we know that C has to be parallel to the purple. If you cross two things, you get a perpendicular vector. We know that the purple is perpendicular to both of them already. So therefore, whatever the cross product is, has to be parallel to the purple vector. So all this is asking you to do is find the cross product of NA and NB. That's it. So how do you do that? Just to recap, our C is going to be, remember, I, J, K, and what do we have here? 2, -3, 5. And what's the other one? 4, 1, -3. 4, 1, -3. You have to be able to do the cross product here. So what's that going to be? That's going to be I times 2 times -3. Sorry, no, wrong pair already. I times -3 times -3 minus 1 times what? 5 minus J times what? 2 times -3, and there's an errant little mark right there. Minus what? Minus 4 times 5, thank you. Plus K times 2 times 1 minus 4 times negative 3. Is it really easy to make a mistake with regards to a sign? Yes. Absolutely. You'll also notice, Tori pointed out this when she came to the extra help session, the definition that they use in the book doesn't put a minus sign in there. It's a really cheap thing they do. Instead, what they do is they reverse the order of the subtraction here. Don't do that! Because the whole moral of the story of determinants is any determinant can be broken down into 2 by 2 determinants, right? 2 by 2, not some like flipped version of them, right? Just remember plus minus plus. Okay. So when we do this out, there it is. Now here's the thing. They're asking for, this is a vector, right? 9 minus 5. Oh, thank you. That's good. Thank you. That would be cool. No, we were having conversations like this in the math office earlier. Okay, so here's the thing. This would be a totally fine answer, right? What could you do to this vector to still have it be parallel to, you know that this is parallel to the purple, right? You could multiply by -1. You could make it a unit vector, right? You could clean it up and just make it nicer. So for example, you could be like 2i plus 13j plus 7k, right? At least they're all now relatively prime, you know? They don't have any common factors. But again, either one is fine. One of the things that makes this section difficult is that you have many different types of answers. They could be, I mean, you could make this look terrible. You could divide by, you could make it unit. It's going to be dividing by, I don't want to figure it out right now. Okay. You're literally just going to do cross the normals. You cross the normals, yeah. What's kind of cool is, what is that all of that math, that these two numbers come into play at all? No. They're totally irrelevant, right? Changes nothing about the vector of intersection, or the line of intersection. What do you get? You get the vector that is perpendicular. You get a vector that is perpendicular to both W and P. What else do you get? There's something else it gives you. James, what else does it give you?
It's perpendicular component on vector.
That's what they just said. Okay. Gives you the area
of a
area of parallelogram, which is only one-upped by parallelepiped. Area of parallelogram formed by what?
Those two vectors.
Yeah, by W and P. Correct. That's the two things it gives you. It's the map. What?
You call that an
Area vector. Correct. Yeah. And you make it minus V3W1. Would you like to learn another cool way to do determinants that you haven't learned before?
Yeah.
Another one? No, let's make sure you master this one before I give you something else. I don't want to short circuit you, which I tend to do on a daily basis anyway, so it's all good. Okay, so let's do 2 example problems. Let's talk about this. So you don't need to really write anything down for these. Let's take a look at example number 1 here. Number 1 says, what happens when you cross I and J? I is the vector that it runs parallel to what axis? No, don't tell me the answer yet. Just hold on a sec. The x-axis, right? The j is the y-axis, right? So this is asking if you cross from I to j, what is the cross product going to be? Jesse? K. It is going to be k, indeed, right. But what happens if you go from j to I? Negative k, that's right. And do you remember what the rule is called? I mentioned it very briefly, and you might have read it. It's called the right-hand rule. If you take your right hand and you sweep from the vector you're starting with to the one that you're crossing to, whatever direction your thumb is pointing in is the direction of that vector.
The same thing in physics.
It is. It is what it is. Exactly right.
9 right-hand rules.
There's like 9 right-hand rules. Yeah.
Yeah.
Okay. Well, you get a perpendicular vector, right? But you also get the area of the parallelogram formed, right? What's the area of the parallelogram formed by V in itself?
0.
Big fat 0. Good job. What? V squared? No, it's 0. What's the area between two things that overlap? Ah, there it is. Now, this is on the record now. Do we know how to quickly find the area of this parallelogram? The area of that parallelogram is just what? The magnitude of what? B cross C, right? The magnitude of that, correct?
Yes.
Now, if you want to find the area, the volume of that three-dimensional parallelogram, which I like saying better than the other word, you need to find the height of this thing. You need to find the height of this thing. If you only have this vector A, how do you find the height of that? How do you find the height? What I mean by the height is the distance from here all the way to the top. This distance. How do you find that if you only have A?
Cosine theta. You only have it?
So look, you have a right triangle right here, correct? You see this right triangle? right? You need this distance right here, correct?
Oh, so, but you don't have theta.
So hold on a sec. You don't have theta, but it'll be in terms of theta. Correct. It will be in terms of theta. Correct. So what trig function do you want to use?
Cosine.
So you know that cosine of theta is equal to what? The height over what?
A over
The height you
over
want.
A over B cross.
No, it's adjacent.
height over A.
Height over A. Do you agree with that? Okay. So therefore we know. I see your hand. Hold on one, Brendan.
Yeah.
Height is equal to A times what?
Cosine theta.
Cosine theta. Are we okay with this so far?
Yeah.
It's magnitude of, right? Magnitude of. Thank you. That's important. Magnitude. Yeah. So what can we say here? If we want the volume of this thing, the volume of this thing is going to be equal to the base, right? Times what?
Height.
Times the height. But do we already have do we have another way to express the height? Yeah, we have correct. Like you got to write the actual full thing. Sorry, like this. Yeah, like that. Like this times the magnitude of A, right? Times what?
Cosine.
Cosine theta. So let's just pause here for look like something. By the way,
Yeah,
does
look
this?
at the dot product?
Yeah, that's a dot product of what?
B cross.
Yeah, this is the dot product of
B and A.
no
No,
B cross C
cross and dot
dot what?
A.
A, because the cross product of two vectors is a what?
A vector.
A vector. So we have a valid operation right there. We have a vector dot a vector. That's valid, right? What is the definition? What is the definition of A dot B?
The components.
There's the components, right? But then what's the geometric way?
Scalar.
The magnitude of what was it? Do you remember?
Oh.
Magnitude of A, magnitude of not A again. I'm having trouble writing today. B cosine what? Theta, which is the angle between. Correct.
Yeah.
Let's go back here. Is that exactly what we have?
No, because the angle between them would be 90 minus theta.
Is it 90 minus theta? No, we defined it. This right, B cross C goes in this direction, right? A is in this direction. We defined theta to be this right here.
Oh.
We defined it. This is actually how we defined it. It is the angle between B cross C and A. So what does this in fact equal? It equals this thing right there. So what do we now have? All of that work is just to say the volume of a 3D parallelogram, which I'm just by dictatorship taking, is going to be, it's called the scalar triple product, I think is what I remember it being called. I don't think they call it that in this book. Because here's the deal. This right here is a vector, right? This is a vector, but when you dot them, what does it become? A scalar. And you kind of see three things multiplied together, as far as I remember. I could be wrong about this, but I'm pretty sure it's scalar triple product. All this means is if you want to find the area of a 3D parallelogram, you cross two of them and you dot it by the third. That's it. That's it. It's kind of cool, though. I really like seeing this because you go from this and you're like, oh, that looks familiar. Oh, it is by definition what we want it to be. It is. You can figure out the next part of this. If I just said B cross C and I asked you to write it in general form, what would you do? I, J, and what? K. And then you'd have B written right here, right? And C written right here. And then you do that cross. It would be I times the cross, the 2 by 2, 2 by 2, 2 by 2, right? When you take this, what are we doing? We're taking B cross C and we're dotting it by what? A, correct?
Yeah.
So when we do this, you're going to get I times what? I times something, right?
Yeah.
Minus J times something. Yeah, and you could do it out. It's not what I want you to focus on right now. And K times something. Do you agree? When you do the dot product of these things, what are you going to get? You're going to take this thing, right? Times A1, right? And then you're going to have this thing right here times what? A2, right? And then what are you going to have? This thing times what? A3. Well, look, these are in the exact same position, right? These are the exact same position. So one thing you can say is B cross C as a vector, sorry, dot A. Anybody want to guess what that, another way you can write that is? The determinant of what? Well, okay, yes, you can rearrange them that way, but how could you write it as 1 3 by 3 determinant? Can anybody see it? So instead of IJ... No, take a look. What I'm getting at is this. See this right here? What can you replace IJ and K with? A1, A2, A3, exactly. This is just A1, A2, A3, B1, B2, B3, C1, C2, C3. That's it. I mean, more cleanly written, you have this right here. You have this. Is it scalar triple product? It is, thank you. More cleanly written, it looks like this. All you've done is you can put the ijk there, but then when you take the dot product, you drop the ijk, and the a1, a2, and a3s go in the exact same place the ij and k's were. So guess what? Just put them there to begin with, and just do the math. Anyway, so you end up with this right here. So if you want the scalar triple product, you want the absolute value of the determinant of this thing. And you know how to find the determinant of that thing. It's a times b2 c3 minus c2 b3, and so forth. There's 3 of them together. Determinant. What'd you say? Oh, there's the word right here. See what I mean? Look, it's not parallelepiped. It's parallelepiped. Parallelepiped, which is also not correct. It's my class. That's what you get to call it right now. Okay. Yay. How many people? The reason I'm reticent and hesitant to commit to that, I have to really think about it, is because when you take 2 matrices, for example, you can multiply a 3x2 matrix by a 2x3 matrix, but you can't do like a 3x2 times a 3x2, right?
Yeah, because they have to know how to.
For example, I could write this as, you can do this one right here. You can multiply a 3x2 times a 2x4, but you can't do a 2x4 times a 3x2. You can't do that. It's just not defined. Directionality is really important. Also, for example, if you have a matrix A, and you multiply it, that's multiplication in matrix land. If you multiply A by B and it has a valid product, B by A almost never equals A times B unless they're unless they're creating an identity matrix, right? So all of that makes me want to be very careful to give you an answer about that. Undoing cross products would be challenging, but it might be doable. That might be something you could think about and come up with a very specific question that we could work on. But basically, you're asking if we have two of the elements, can we find the third? That being like the A vector. Careful. My guess is yes, but you'd have to be very, very careful about it. For example of this directionality of math, have you heard of modular arithmetic?
Yeah.
I'll give you a basic idea here. Ready? Let's see if you can. Those of you that know about this, don't give the answer. Those of you that have not heard about this, let's see if you can figure out the pattern. Ready? 17 mod 2 is 1. 17 mod 5 is 3. Oh, sorry, is 2. 17 mod 4 is 1. 17 mod 10 is 7. Anybody know what modular arithmetic is yet? What is it, John?
I know the pattern.
What's the pattern? Just tell me what it is.
Like the remainder.
This is a remainder, exactly. So this is why it's really, really challenging, because here's the thing. Let's say I said something mod 3 is 2. Do you have any idea what that something is?
No.
It could be an infinite number of things. You have many, many, many different options, right? This is an irreversible operation without a key. This is a totally irreversible operation. You can't do it in reverse. Because look, how many things when you divide, this thing is asking, give me something that when you divide it by 3, the answer is 2. The remainder is 2. How many numbers are there? That's 3n plus 2, right? And n could be, find me the volume